Okay, hopefully you can see my screen. Okay, so good morning and welcome to this webinar. As Stephen said, we're going to be talking about the countdown to the last free JDK update. This is really quite significant because there are a lot of changes happening to Java at the moment, and not just from a technical perspective. What we're seeing is changes in terms of the way that the JDK is developed, and more importantly, changes in the way that the JDK is delivered and updates to the JDK are made available. So we're going to talk through all of these things, explain what's going on, how this will impact you in terms of your choices for deployment of the Java platform. Now, what I'd like to do is I'd like to start with a quick poll. So I've put together a question which I'd like to ask you, the audience. So hopefully we can put the poll up. There we go. And the question is, how quickly do you move to a new release of Java? And I've given you 5 possible answers. First is we deploy it into production before it's released. So you're one of the people who's really on the leading edge of adoption of the new releases. Second one is as soon as the release is generally available. So as soon as it's actually out there and ready to go, you instantly start using it. Third is we wait for a few updates to make sure that things are stable, and then we migrate our application to it once we're happy with the stability of the platform. Fourth option, when public updates to the previous release end, so really when you're forced to move, that's when you move. And the fifth option is, what you mean there are new versions of Java? So I think we probably had enough time, just have a few more seconds, and then if we close the poll and we show the results, but yes, there we go. What we see is that, interestingly, most people in this case actually wait until the public updates for the previous release end. And about a third of the audience say that they wait for a few updates to ensure stability. This is quite common in terms of the audiences I've been speaking to. Normally, I see this maybe with a few more people who actually go for the updates, waiting a few updates rather than waiting until the last public update is available. But so what we'll do is we'll return to the slides and we'll start talking about what is actually changing and what this means. So first thing is, let's talk about what we're used to in terms of Java. What have we been able to do and how have we been expecting Java to be delivered? And the first thing is the development of the Java platform. Java is sort of 23 years old now. And what we've seen is that the development of new releases actually takes quite a lot of time, which is sort of understandable, but it really can take quite a long time. And what I did was I looked through the sort of more recent releases and figured out just how long it was between each of those releases. And if we look at JDK 6, that was just over 2 years between JDK 5 and when JDK 6 was released. In the case of JDK 7, that was a whopping 4 years and 8 months after JDK 6. Now, to be fair, there were a few other things that kind of got in the way. Sun was acquired by Oracle. There were some issues around the JCP and the Apache Foundation that slowed things down. But 4 years and 8 months between JDK 6 and JDK 7. Then we had to wait another 2 years and 8 months between JDK 7 and JDK 8. And finally, if we think about JDK 9, we had to wait 3.5 years from JDK 8. Again, there were some issues there which we'll explore a little bit more in a moment. The other thing is thinking about how long we have to migrate from one version to another. When I asked people about how quickly they move to a new release, one of the more common responses was we wait until a few updates after the release of a new platform, and then we move our application. So we're confident that the stability is there. And again, I looked at the amount of time that we had to do this in previous releases. And if you look at JDK 6, we had 2 years and 11 months after JDK 6 was released of public updates to JDK 5. Plenty of time, nearly 3 years to migrate from JDK 5 to JDK 6. JDK 7, over 18 months of public updates to JDK 6 once JDK 7 came out. So 18 months, over 18 months to migrate from JDK 6 to JDK 7. In the case of JDK 8, you had just over a year to migrate from JDK 7 to JDK 8. So as you can see, okay, the numbers are coming down, but you've still got plenty of time to look at what's changed in JDK, test your application with the general availability to release, and go through some testing and make sure everything's working before you're happy, and then do the migration. The other, as I say, the thing about this is it does allow you to be confident that when new changes are introduced to the platform, which might be things that are quite significant, then it gives you confidence that after a few releases, any things that might need to be changed have been ironed out, and so you're ready to use that release. So if we look at what the Java platform is today, we can use 3 words to describe it. First is stable. So Java as a platform is very stable. As I say, it's sort of 23 years old. A lot of work has gone into it, literally thousands of man-years of effort. And it's been very carefully planned. There's been a lot of work to make sure that as a platform, everything is very stable and rock solid. So you know that when you run your applications on it, you're not going to have problems with the platform itself. You might have to change your application, but you're not going to have problems with the platform itself. Second thing is it's secure. Right from the very beginning, Java was developed with the idea of security in mind. If you think about the ideas behind Java with applets and so on, it was designed to have code that could be moved around on a network, potentially untrusted code, but the way that the code was then verified was specifically designed to work in that way. Since then, a lot of work has gone into making sure that Java is even more secure and reliable in that respect. And wherever issues come up, security patches get issued very quickly to address any issues that people have found. Often this is in things like protocols that are used, so functionality which is outside of the core area of Java but needs to be addressed because Java actually uses it. And then the third thing that we're used to with Java is it's free. You can go to java.oracle.com and you can download the JDK for free. You don't have to pay any money for it, and then you can use it for your applications. If it's desktop, if it's a server, you don't have to pay anything. And again, when you need to update to a bug fix or a security patch, then you can just go and you can download those patches, you can install them on your machine and get it up to date, all without having to pay any money. So this is what we're used to today. What we need to do now is we need to look at how that's going to change in the future. In September last year, just before Java 1, JDK 9 came out, and at the same time, Oracle made a number of announcements about how they were going to change the way that the JDK was developed, how they were going to change the way that it was delivered, and how you were going to get access to updates. So the first of these is the fact that the JDK has a new release model. Rather than having to wait 2, 3, or even 4 years between major releases of Java, now we only have to wait 6 months. So the idea is that every 6 months, in March and September of every year, there will be a new JDK. JDK 9 started that back in September last year. We've already had JDK 10 in March this year, and work is going on, and we will see JDK 11 in September of this year. So that process is in place. Everything seems to be working very nicely. The idea behind this is to make the development of the OpenJDK Java platform more agile. I mean, this is a much more modern way of developing software. It's much more responsive in terms of the requirements. It's much faster in terms of getting the features to the users. So rather than having to use the previous target, which was a release every 2 years, and as we saw in the slide I showed earlier, they never even managed to get a release out every 2 years. It's about getting a release out much more quickly so people can get access to new features, they can use them more quickly and get them into production. Now, how this is going to work is by changing completely the way that features are selected for a particular JDK. In the past, when the JDK developers started a new version of Java, they would sit down and they would think about what features they wanted to include in that release. They would start developing them, We'd have a plan, and then only when those features were finished would they actually release that next version of Java. Ideally, that would be within the timescales that they'd set themselves, but often that wasn't the case. If we think about JDK 9, because of the introduction of modularity and the fact that a number of people had issues with the backwards compatibility that affected, JDK 9 got delayed on at least 2 occasions. I think probably was even 3 occasions. So rather than doing it that way, the idea now is to say, okay, we will release a new version of Java every 6 months. Whatever features are ready at the point where they need to freeze the code, those are the ones that are going to go into that release. If a particular feature is not ready, it still needs more time to develop, then it will be delayed until the next release or a later release. Only when it's ready does it actually get put into the code. Now, because we have a much faster release cadence, new release every 6 months, it just isn't practical to start issuing updates and providing support for all the versions of Java that are going to sort of pile up behind us. So what Oracle have said is that rather than having all releases supported for a long time, they're going to use the same sort of approach that Ubuntu do. And they will select certain releases and they will classify them as a long-term support release. Right now, to get things started, JDK 8 has been classified as a long-term support release. The next one is going to be JDK 11, and then there will be a new long-term support release every 3 years. So that makes a lot of sense. So every 3 years, there'll be a new long-term support release JDK. As I said, next release is JDK 11. Important thing is that, as has been announced, the public updates of JDK 8 will stop in January of 2019. If you're thinking about using JDK 9 and JDK 10, because these are what are called feature releases, they will only get updates for 6 months. So they're not long-term support releases. And that means that as feature releases, once the next release comes out, all updates to the previous one stop. It's only the long-term support release that will get updates beyond 6 months. We'll explain how you get those updates in a moment. The other thing with JDK 9 was that it marked quite a change in the approach to how features are delivered in terms of the JDK. So it was quite a significant change in terms of Java. The reason for this is that, again, because Java at that point was sort of 22.5 years old, lots of new features have been added over time. And that's a really good thing because now we have lots of extra things that we can do with Java that we couldn't do back in the very early days. But the problem is that things have been added, but things have never really been removed. Nothing of any significance has ever been removed from Java. And clearly, if you go back sort of 20 years, you'll find that there were technologies and approaches to development of applications that were very different to the way they are today. And in fact, they're so different that there are things that we literally don't use anymore. So it made a lot of sense to say, okay, in JDK 9, we are going to start removing some of these older features, the things that people just don't really use anymore. They're not required for developing new code at all, and start doing some housekeeping. Start with really quite small. If you look at the APIs, the standard class libraries, there have been a lot of classes that have been deprecated. In the case of JDK 9, 6 methods and 1 class were removed. So not very much, but it was significant because it was required to simplify the modularization. They found that there were some very odd combinations of things that were being used between different modules. To make a nice clean separation of the module system, they found that there were these 6 methods and 1 class that needed to be removed. In addition to some of the APIs, there were a variety of redundant features that were eliminated, things like JHAT tool, the JVM tools interface, HProf agent. A number of the garbage collection options that have been used in the past were deprecated and then removed. Things like the incremental concurrent mark sweep mode went away completely, and there were some various options associated with that that also disappeared. And Another thing that changed in JDK 9, sort of related to this, was the introduction of a unified logging system for the JVM. And you might think, well, okay, so how does that sort of help with housekeeping? How does that affect things? But what it meant was that a lot of the flags that we use on the command line changed between JDK 8 and JDK 9. And in fact, there are also a lot that were removed from JDK 8 in JDK 9. So things like print GC details that a lot of people do use, those have changed now. And so there's a different way of doing it, -xlog::gc or -xlog::gc star. The important thing here is that there are about 50 command line options that were available on JDK 8, which if you use them on JDK 9, so if you just take your application and you try to run it on JDK 9, it will prevent the JVM from starting. So it won't just ignore them, it'll actually say, no, I don't understand these, they're invalid, I won't start. So that is quite important. Now we'll skip JDK 10, there were a few things that changed in JDK 10, but JDK 11 is really significant. The housekeeping is continuing in a big way in JDK 11. So there are over 6,000 API elements, that's classes, methods, interfaces, and so on, that are being removed in JDK 11. Now, a large number of those come from one particular area. So there is this aggregator module called java.se.ee. And this contains some pieces of technology which, as I said, have been added over time, but very few people now use. Things like Corba for interaction between remote systems. Very few people use Corba now. Certainly there's no code, as far as I know, that's being developed, new code, which uses Corba. You have the activation framework, which is related to the Java Beans framework. You have the XML binding, which is the JAX-B API. And then you have a set of web services APIs, which are all related to the older style of doing things, the SOAP-based way of doing web services, rather than the much more popular, much more common RESTful web services way that most people do this. But these are things that you need to be aware of, because these are going away. If you have code that uses Corba, if you have code that's using old style SOAP-based web services, this is going to impact moving an application from JDK 8, even JDK 9, to JDK 11. There's also some analysis I did where there's literally several hundred command line flags that have been removed in JDK 11. So again, you need to be very careful in terms of testing your code to make sure it works on JDK 11. The sort of net effect of this is that the developers of Java are now saying that compatibility, which is something which has always been a very key point for Sun and then for Oracle since then, compatibility is not really guaranteed in the same way that it was, because the developers of Java want to continue this housekeeping and they want to make sure that they can remove things where it makes sense. So the idea is that new versions of Java may include breaking changes. So they might remove things, they might add new features which could potentially break backwards compatibility. If they do decide to remove things, then they will deprecate them first. Deprecation has been around since JDK 1.1, and if you use a feature which is likely to be removed in the future, you will get a warning message when it's deprecated. That way, you know, when you run your code, you'll see the warning message, you'll go, okay, so I need to think about what I'm going to do when I move my application to a later version when this particular feature is actually removed. Now, the developers have said they will give you a minimum of one release of the JDK as a warning. Well, I guess they couldn't give you any less than that, because if they didn't give you at least one release as a warning, then they'd just be removing it straight away. But because of the new release cadence, that means that you could only get 6 months notice about the removal of a feature. It becomes deprecated in one release, and then the next release, it's gone. So that could be 6 months notice, and you have to make changes to your application. Now, another thing that Oracle are doing is they're simplifying things in terms of the binaries. So this is about converging binaries. And I put together this Venn diagram so we can see how the different areas of functionality fit together in terms of the JDK. Now, at the core, what we have is the Java SE specification. That's what we get from the JCP, There are JSRs that define the Java SE specification, the reference implementation, the TCK, and so on. That's the Java virtual machine specification, the Java language specification, and all of the core class libraries. If you want to call something Java, that's the very minimum set that you need to implement in order to enable you to comply with Java. Around that, you then have the OpenJDK. The OpenJDK is a superset of Java SE. There's a whole range of things that go into that in addition to the Java virtual machine, the libraries, and so on. So there's things like the Nashorn scripting engine is a good example of something that goes into OpenJDK. This is open source. OpenJDK is the reference implementation released under GPL v2 with class path exception license, reference implementation for the Java SE standard. So everything in OpenJDK is open source. You can use it under that license. Then at the moment, we have the Oracle JDK. And the Oracle JDK is, again, a superset of the OpenJDK. There are a number of features which Oracle include in their JDK, some of which closed source, some of which are open source, and they're not necessarily part of the OpenJDK. Well, in fact, they are not part of the OpenJDK. What Oracle are doing is simplifying that so that there are not going to be, in the future, any differences functionally between a binary that you build from the OpenJDK source code and the Oracle JDK. So now we'll just have the core Java SE functionality, and then we'll have OpenJDK functionality. That means that the Oracle JDK will be the same as the Zulu JDK that we build from source code to produce our version of the JDK. So JDK 10 and earlier, we have 3 circles. JDK 11 and later, we have 2 circles. How they're going to do that is in 2 parts. So the first is that Oracle have said that some of the closed source parts of the JDK that they have been using up until now are going to be made open source and contributed to the OpenJDK project. Most obvious of these are things like Flight Recorder, which is now going into JDK 11, Mission Control, which is already in JDK 10, and there are a few other things like application class data sharing, getting that made it into JDK 10. So they're going to take some of the parts from the Oracle JDK and contribute them to the OpenJDK. Then there are some other parts which are going to be removed. So the browser plugin, which very few people use now. In fact, it's almost, it's very hard to use the browser plugin because most browsers won't let you actually use it because they've changed the interface. It's always been a bit of an issue from a security perspective, and so the Oracle developers are going to be very happy to bid a fond farewell to the browser plugin. Again, very few people using that because most people now use things like HTML5, they use JavaScript and CSS in order to develop web-based applications. Java Web Start. This is a piece of technology, again, has been around for a long time, but there are still people who are using that as a way of delivering code across a network where you can have like a sort of web front end, and you can check for updates and only download the updates if they're required. So Java Web Start, again, proprietary technology, not being open sourced and going away. JavaFX, slightly different because it's not actually closed source. It is open source. There's a project under the OpenJDK called OpenJFX, which is separate from the OpenJDK, so it's not part of it. And so that means that although JavaFX will not be included by default in the Oracle JDK, you can still download the source code, you can still build it. There are some people in the community who are producing binaries of that, which you can use if you need to. But that's effectively what Oracle are going to do. They're going to add some bits, remove some others. Now, let's eliminate some confusion, because a lot of people look at all these announcements that have been made and they think that they see something that's not quite the way it is. What do I mean by this? Okay, so I've said, Oracle have said, that there will be a long-term support release every 3 years. And a lot of people go, okay, that means that rather than having updates for only 6 months, I'll get updates for 3 years. No, it does not mean that there will be 3 years of free updates. Why is that? Well, what's going to happen is that from JDK 11, because we have this convergence of binaries, which means that the Oracle binary will be the same functionally to one built from the OpenJDK source code, Oracle are changing the way that you can use their binary. They are saying that you can still go to java.oracle.com, you can still download the JDK from there, and you can use it for development, you can use it for testing, you can use it for demonstrations. But if you want to deploy the Oracle JDK binary into production, you will need a commercial license from Oracle. Oracle are now also providing a second set of binaries, which are built purely from the OpenJDK source code. If you go to jdk.java.net, you can download those from there. So as of JDK 11, the only free binaries that you will be able to get are ones built purely from the OpenJDK. They will not be the same as the, well, they will not be the same in terms of the actual binary as the Oracle binary. And subsequently, that means you will not get support for the OpenJDK binary. Support is only going to be provided for the Oracle binaries, and the long-term support release is only the Oracle binary. What this means, this is very significant, is that if you want to continue to receive free updates to the JDK, you are going to have to change your JDK every 6 months, because you won't get any updates for older versions beyond 6 months. We're already seeing this. I updated Java on my laptop and I got this message when I did it. And it said, changes are coming which will impact your access to future releases of Java SE from Oracle. Corporate users will be impacted as soon as January 2019. As I said, from January next year, JDK 8 updates, free updates, will stop for commercial users. Updates for non-commercial users, so if you have it on your laptop or your desktop at home and you're running something like Minecraft, you will still get updates free of charge until the end of 2020. But you have to be a non-commercial user in order to be able to use that. To make this clear, here is a slide which is a slightly adapted from one that was used by Oracle. I say it's slightly adapted because it's been changed to reflect the change that they announced about support for JDK 8. So all the things that are in orange are the things that are commercial support, commercial available from Oracle. So things like JDK 6, JDK 7 have stopped having public updates for quite a long time now. JDK 6, in fact, will soon stop even commercial support. So as of the end of this year, Oracle will no longer be providing any support for JDK 6. JDK 8, as I said, you get free updates at the moment. That will continue until January of next year. If you want to use the long-term support release, that's in orange, JDK 11, long-term support release, then you need to have a commercial agreement with Oracle. In terms of the OpenJDK releases, then those are the ones in green. And you can see that we go from 11, 11.01, 11.02. There is no 11.03. You have to go to 12, then 12.01. So you can see that you have to move every 6 months to a new JDK if you want to continue using it for free. And just to sort of put that in a different visual form, what we see here is what we call the support cliff. So every 6 months, updates for the previous release stop. That means that if you want to get free updates, if you don't want to have to use the commercial long-term support release, then you're going to have to change your release every 6 months. So I said that at the moment we can think of Java as being stable, secure, and free. And that's still the case. Java is still stable, it is still secure, it is still free. But the big change is that you can only have 2 out of 3 at the same time. What do I mean by that? Well, let's say that you want something that's both stable and free. Well, you can do that, but it means that you're not necessarily going to be secure. Because in order to be stable and free, what you're saying is, okay, JDK 8 is stable, I want to carry on using that, but I'm not going to get any more updates, so I won't get security patches beyond January next year. So I could potentially be exposing myself to a security problem, even though I have a stable platform and I'm not paying for it. If you want to be secure and you want to be free, then you can do that, but you're doing it at the cost of stability. If you change your JDK every 6 months, you will get these security patches. You will not need to pay for it, but you're going to be potentially having problems with stability because, as I said, JDKs can introduce potentially breaking changes between releases, and with only 6 months warning of a removal of a feature, you could find there are problems in terms of migrating an application from one JDK to another as things change quite rapidly. If you want stable and secure, you can do that, but you can't get it for free, because if you want to use JDK 8, for example, and you want to continue getting security fixes, then you will need to pay for a commercial support contract. So it's not going to be free. So that's why I say you can choose 2 out of 3, but you can't have all 3 at the same time, which is what you used to. Let's talk a little bit about Azul's Zulu Java as an alternative and what we can do in terms of that. So Zulu Java, as I said, is simply a binary distribution of OpenJDK. We take the source code from the repository, we run the build scripts on it, we do everything as is supposed to be done in order to generate the standard binary. What we then do is we run the standard TCK tests on that binary. Even though the OpenJDK is the reference implementation, so it should pass without any problem, we run all the tests to make sure that nothing that has been built has any issues with it. In terms of what we make available, we go all the way back to JDK 6. So we take 6, 7, 8, 9, and 10. We have quite wide platform support. So we have the usual suspects. We have Intel 64-bit versions of Windows, Mac, and Linux. We also have Intel 32-bit versions of Windows and Linux. Oracle are no longer supporting 32-bit versions of these. Oracle have also decided that they don't want to support embedded Java anymore. So we have ARM32, ARM64 versions available, and PowerPC as well if you want it. So if you go to azul.com, download Zulu, you will find a wide range of platforms, a wide range of versions available that you can download for free. So there's no cost associated with this. You can download them for free. What we also do is we provide extended support. So we are offering the same sort of concept in terms of saying, okay, we will take the security patches, we will take the bug fixes which are released in the current version of the JDK, and we will backport them to older versions. We're already doing this for things like JDK 6 and JDK 7. We work with people like Red Hat to do the backporting of these fixes. So we can do that. We also push the fixes into the OpenJDK projects, and we do make the binaries available on our website. But in terms of when those binaries are available, there is no SLA in terms of when they will actually be made available. What we're doing at the moment is we're saying that for JDK 8, so Zulu 8 will be supporting this until March of 2026. So you have a long time if you want to continue to use JDK 8. You'll have a long time to be able to continue using that and figure out how to migrate to a later version at some point. In terms of our long-term support releases, we're going to follow what Oracle are doing. So JDK 8 is a long-term support release, JDK 11, JDK 17, and so on. Our long-term support releases, we will have 9 years of active support. That means backporting fixes. And then we'll also follow that with another 2 years of passive support. It's passive support. We won't be issuing updates to the particular release, but we will fix bugs if people are still using it and they report them, and we can resolve it and produce a fix for it. In addition, we have a different thing that we call medium-term support. And the idea here is that rather than having to wait 3 years between long-term support releases for a release that you want to deploy into production, there might be a feature that you want to make use of that's between those releases. And so what we're doing is we're saying that 2 of the releases between long-term support releases, because there are 6 releases, so we're going to pick 2 of those, and we're going to say, okay, let's provide medium-term support. Medium-term support means that we will support it until 18 months after the next long-term support release. So you've got 18 months to migrate from a medium-term support release to the next long-term support release. Now, that sounds very complicated. hopefully this picture makes it a little bit clearer. So we have the same diagram we had before with the support cliff. So we've got the gray blocks that represent the OpenJDK binaries with only 6 months of support. We've got the red ones, which represent the Oracle long-term support, which are commercial. And then we've got the blue ones, which are the Zulu ones. We have the same long-term support release as Oracle, but then we have these medium-term support releases in between, where, as I say, they have an overlap of 18 months, the next long-term support release, so that you can use them and then have 18 months to migrate from one release to the next. So just to summarize then, Java is changing, not just from a technical perspective, but from a development and delivery point of view. So faster delivery of new features, 6-month release cadence, very good. We get new features much more quickly. Long-term support release is going to be every 3 years, but that doesn't mean free 3 years of updates. Doesn't mean free long-term support releases. With the changes to the way that Oracle are making their binaries available, you won't be able to use the long-term support releases for free. There will also be no overlap of updates if you're using OpenJDK binaries. Every 6 months, the updates to the previous version will stop and you'll need to move to the next one. Azul can help. So we have extended support available for more releases, not just the long-term support releases. We have the medium-term support releases as well. We're trying to make it easy for you to migrate applications between releases, so you've got time, you can look at the stability and so on. And it's important to understand that when we talk about support, we're not just saying that we can do the backporting fixes. We have a very highly skilled team of engineers who, if you do have a problem which is in the JDK and you need a response to that quickly, our engineers can help you find out what the problem is and then develop a fix for it so that you can get your system back up and running very quickly. So with that, I'm going to say thank you very much. You can get more information from our website. There's the link here from azul.com/products/Zulu and Zulu Enterprise. So what I'm going to do now is have a look and see whether we have any questions and see what we've got here. Right. Am I the only one experiencing sound quality problems? I don't know. Difficult to know. Right, hang on. Question to make sure I'm hearing this correctly. Okay, I don't see a question there. Hopefully there'll be a follow-up question to that. There's another question here about Java. Oh, hang on, no, let's not look at that one. Support does include security patch releases if we sign up to Zulu. Yes, it does, absolutely. If you sign up to Zulu, you will get the backported security fixes, you will get backported bug fixes. So very much it will give you full compliance. So if you're in a situation where you need to have a fully supported version of Java, then it will be fully compliant with all of the relevant standards and so on. So all security fixes will be backported. One other question here we have is about Java Web Start, and are there any alternatives in terms of open source for Java Web Start? And the answer to that is, well, yes, there is, but I had a look at this the other day, and there's Ice-T from Red Hat, but that only runs on Linux. And a lot of people use Java Web Start on Windows. There are a couple of open source projects around this, but they are very old and most of them haven't been maintained for a long, long time. So it's a little difficult to know quite what's going to happen with Java Web Start users in the immediate future. One question, this is for a minimum for 8, but maybe includes in 6 and 7. Yes, so as I say, we actually provide support for code all the way back to 6. Now, as I said, Oracle are terminating commercial support for JDK 6 at the end of this year. Because we've spoken to a number of customers who are not able to move off JDK 6 in the time that they have available, we're actually extending our commercial support of JDK 6 for another year. Whether we extend it further than that, we may well do, but we're certainly committing to extending our support for JDK 6 for another year, so it gives people time if they want to migrate to a newer version. JDK 7 will still be continued to support for longer than that. Right. Can we redistribute a license Zulu JDK in an embedded product to runtime to customers, or do customers also need a license Zulu? No, if you want to talk to us about the embedded side of Java, so we're not talking about desktops or servers, then yes, if you license Zulu from us, you can provide it to your customers as part of runtime. They will not need to have a separate license from us. So we would license it to you. You would then provide it to your customers, and that's completely fine, and there's no issue there. So that seems to be the end of the questions. Yeah, so hopefully this has been useful to you, and thank you very much.